All right, ladies and gentlemen, we have made it. You are officially saying goodbye to Algebra 2 for a little bit and moving on into the trig section. This is going to be different. It is going to be great, but it's going to be different. So to introduce us into this lesson, we do need to take a time out and just learn the new vocabulary that comes with it. We didn't have to really do this in Algebra 2 because luckily for you guys, you learned most of the vocabulary in your Algebra 1 class. So give a shout out to your Algebra 1 teachers, send them an email, thank them, whatever you need to do, but we didn't really have to spend that much time learning definitions. In this section, we are going to have to take the time out and learn the definitions because this is completely different. You have heard some of the terms in geometry, so that is the good news. But some of it will be like new, or you might have forgot. So we're just gonna dive right into it. We're going to learn angle terminology, and that's gonna help us find rotations and understand them and how that rolls out into the coordinate plane. So before I even get into these definitions, I drew a lovely coordinate plane for you guys. I took a time out and labeled your first quadrant, second quadrant, third, and fourth to remind you guys. You will need to know it. And with that also comes the degrees that fall into it. So remember, your first quadrant includes from 0 to 90 degrees, any angle in between there. Your second quadrant includes from 91 degree all the way into 180. Your third quadrant is 180 to 270. And then your fourth quadrant is 270 all the way to 360. And then that plays out because if I was to draw an angle all the way around, rotating that, it would form a circle. And there are 360 degrees inside your circle. So that is where that comes from. All right, let's just jump right in. So, first definition here is standard position. All that really means is we're talking about an angle here, and we're going to refer to that angle in standard position if its vertex is at the origin and its initial ray points along the positive x-axis. A whole bunch of fancy language for something very simple. First off, positive x-axis, I know that's this side of my x-axis here. That was the first thing that stood out to me. Second thing said that its vertex is at the origin. Well, I know my origin is right here. When they're referring to the vertex, they're referring to like that little dot that is connecting both those lines to form an angle. So when I draw something like this for an angle, this right here is your vertex. Okay, if I drew like a right angle, this right there, that's still your vertex. Okay, so I have my vertex at the origin. I'm good to go. I want to draw an angle in standard position. Well, I just need to have my initial ray along the positive x-axis. When I'm saying my initial ray, I'm just referring to your starting line of your angle. So I just need a line that's starting right along there. And then to form my angle, I can do something like this. This is an angle in standard position. I have my vertex at the origin and my initial ray along the positive x-axis. I could even change my angle here. I still have my initial ray on the positive x-axis, my vertex is here, but I can end it over here. And now bam, that is still an angle in standard position because I have my initial ray along the x-axis, my vertex is at the origin, and by the way, this ending line here, that's called the terminal ray. Think about it, it's terminating, it's ending your angle. So I could, even if I wanted to, keep going like all the way around and have an angle in the fourth quadrant instead. That's still an angle in standard position. Going all the way. So hopefully you guys are understanding that. That's your first definition. If you need to, take a time out, rewind, digest what I just said. Your second definitions here is going to refer to positive and negative rotations. So notice when I drew my angle here, I started along that, my initial ray started along the x-axis, and I always went counterclockwise. That's how all of your angles have been drawn up to this point. And that's called a positive rotation. When your initial ray is rotated counterclockwise to the terminal ray, that's when we're calling a positive rotation. So that angle right there is a positive rotation. I know that because let's just say I asked you to tell me like what the measure is of that angle. I would say it's like 290 degrees, let's just say. It's a positive number. If I wanted to draw another angle, hypothetically speaking, let's just say something like this angle here. I started and I went counterclockwise to end. My terminal ray ends there. So let's just say this is like 130 degrees. Again, a positive rotation, a positive angle. So a negative rotation is going to be when your initial ray is rotated clockwise to the terminal ray. So I still have my initial ray here, but let's say now I changed it and I went down here. Well, I went in my clockwise direction and I'm now asking you for that. Well, this is going to be a negative angle, a negative rotation. And since it is going to be a negative rotation, that means I'm going to have a negative angle. And when this whole thing happens, when I start going in a clockwise direction, all of your quadrants switch. So this really, I guess I'm going to change markers for you. Hold on one second. So I went a negative direction here. This really now becomes your first quadrant. This now becomes your second quadrant. This now becomes your third quadrant, and this now becomes your fourth because you went in that clockwise direction. So this would really be like an angle between 0 and 90 degrees. So I don't know, hypothetically, let's just say that's negative 30 degrees. If I kept rotating here, let's just say, and I expanded it now here, and I'm like, okay, what's this angle here? Well, I'm in my second quadrant. I went clockwise, so I know that it's a negative angle. So it's going to be negative, I don't know, let's just say 150. It's in between 90 and 180. So that is a negative rotation. Positive rotation is what you're always used to. Negative rotation is when you're going clockwise. A little confusing. Again, if you need to, take the time, pause the video, go back and digest it. Reference angle, that's the last one I'm throwing at you guys for today. A reference angle is a positive acute angle that is formed by the terminal ray and your x-axis. Sorry, I had to erase my board. So it is formed with your x-axis, that's your first huge information there, and the terminal ray. So for example, let's just say I want to have a creation of a reference angle. Let's say I have, this is my angle here, okay? And I know it's going to be a positive because I went in the counterclockwise direction. So let's just say this is 145 degrees, hypothetically, right? So my reference angle, well, the definition said 1, it's acute. A reminder, acute angle means it's less than 90 degrees. So it will always be less than 90 degrees. And it's formed from the terminal ray and x-axis. Well, you guys should know your x-axis is right here. My terminal ray, this is the ray that's ending. So this angle there, which my marker is not working, this angle right here, that's representing your reference angle. How do you figure that out, you might ask? Well, I'm going to take 180 and I'm going to subtract 145. Which is going to leave me with 35 degrees. And that's what that is. That's your reference angle here. Notice it's an acute angle. It's less than 90 degrees. and it's between my x-axis and that terminal right there. So your reference angle is 35. You might be wondering, where did I get the 180 from? I got it from because I know that 180 degrees is my mark on that quadrant there. So be mindful of that. You should always be using 180, and you should be using 360 because I'm always along my x-axis here. If I wanted to do another one, let's say I change this angle here to 120 degrees, okay? So 120 degrees, I have that formed here. Again, my reference angle, it has to be the acute angle. It's between 0 and 90. So in this case, I would just be doing 180 minus 120. 60 degrees would be my reference angle there. Okay? And that is your key definitions here. I'm giving you 3 today. You'll get some more on Thursday, but those are your key definitions for this. Please take the time now, if you need to rewind, understand the language, get used to it, and all of that. Continue on when you are ready. This right here, quadrant 1, this is just me writing out like what the angles are in each quadrant. Quadrant 1, we just said between 0 and 90. Quadrant 2, between 90 and 180. Quadrant 3, 180, 270. Quadrant 4, 270 to 360. And remember, that is if I have a positive rotation. So I now want you guys to continue on. I'm going to do the first example with you. So for each of these here, I want you, the Greek letter, by the way, that's theta, draw a rotational diagram. I'm going to show you what I mean by that. So I want you to draw a rotational diagram, and then I want you to identify what quadrant is the terminal ray ending, and then what is that reference angle going to be. And reminder, reference angle, that's what we just did before. We know it's an acute angle. So the first one here that we're doing is 145 degrees. So I know that it is 145 degrees. That has to be a positive rotation because I have a positive value there. And I know that I'm falling in my second quadrant because that's in between 90 and 180 degrees. So that is a rotational diagram right there. That's all you have to do. That's your first step. Then it's asking you what quadrant. Well, we just discussed that. So quadrant is the second one. My reference angle, I'm going to do an angle symbol like that. A reminder, your reference angle is between 0 and 90 degrees. And it's also along your x-axis. So I'm going along my x-axis. I know it has to share my terminal ray. Well, my terminal ray is here, so that must mean that it's talking about that value there. And then to find out your reference angle, I'm going to take 180 minus 145, which will give me 35 degrees. And that's my reference angle. I want you guys to complete the remaining examples there. So do 320, 610. Let's talk about 610. If you are not sure how to get 610, because I told you guys at the start, there is only 360 degrees in a circle, well, you can take the shortcut of doing 610 minus 360, because that's how many degrees there are in a circle, which will leave you with 270. And that is really the angle that they're talking about here. So you're going to draw one full rotation around, because that's 360 degrees. And then I'm going to go all the way around until here. And I guess you can remove that. That is your rotational diagram for 610 degrees. Keep in mind, if you have a negative, like negative 310, you should be rotating the other direction. So I would be rotating clockwise. Take the time to do this. Ask me if you have questions. I will be scheduling a Google Hangout for Wednesday to review this information because I know it's confusing. Good luck, have fun, enjoy.